Hi everyone, I hope you're doing well, and this is problem sheet from acid and base chemistry. I have done a lesson on acid base as well, in which I have discussed all the major topics related to acid and base, especially the concept of acid and base and cardio. So let's start this question. Of the following, which of the following is a strong acid? We all knew if you are going to compare the strong acid, first of all you have to generate its conjugate base. So conjugate base is what? Removal of hydrogen. Okay, so once you remove this hydrogen, it will form this negative. Clear? And if you are going to remove this hydrogen, it will be this negative, and here this negative, and here this negative. So this is my conjugate base, and we all knew acidic strength is directly proportional to electron withdrawing group. So more the withdrawing group, more will be the acidic strength. And you can see here we have 3 fluorine one, and fluorine is a withdrawing one. So 3 fluorine has maximum strength, and it can stabilize the conjugate base. So stable the conjugate base, that means stronger the acid. So 1 will be B. Now move to next. It is talking about lowest pKa. Lowest pKa. What does it mean? Low pKa means Ka should be high. Ka high means acidic strength high, and we all knew acidic strength what? Directly proportional to again electron withdrawing group. Clear? So again I am going to eliminate the proton and generate its conjugate base. So here we have this one, here this one, here this one, and here this one. So out of fluorine, bromine, iodine, fluorine is a strong withdrawing one, and it will stabilize the conjugate base. So this is the most acidic. Clear? That has the lowest pK, means highest K and highest acidic. Now the third question is talking about which of the following molecule, which one has the highest pKa? Highest pKa means Ka should be low. Ka low means acidic strength should be low. Clear? And low acidic strength is by donating group. So first of all we have to eliminate the H plus. So there is a conjugate base O minus, O minus, O minus, minus, and minus. Everyone has withdrawing except E. You can see E has a methyl group, and methyl is a donating one, so it will destabilize the conjugate base. That's why that has the highest pK, means lowest Ka and less acidic. Now the question number 4. Strong acid. Again we are going to eliminate the hydrogen. Negative, 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 and here as well the negative. In this case, here we have a different atoms, here oxygen, here oxygen, here oxygen, but here nitrogen. And if you applied a cardio, C for charge means positively charged species has the highest acidic strength, then neutral, and then negative. Here everyone is my negative in conjugate base condition. Next is atom. Atom means atom has 2 trend. If you are moving left to right in a periodic table, electronegativity increases and as well as acidic strength increases. Means if you look at moving left to right, then acidic strength increases. And if you look at the positioning, here boron, here carbon, here nitrogen, here oxygen, and here fluorine. If you move like this, acidic strength increases. Clear? So here we have nitrogen and oxygen. We all knew oxygen is oxygen has more electronegativity. So oxygen is more acidic than nitrogen. So we can eliminate the last option. Now you have A, B, and C. A has a donor group, you can see, because after that now move to resonance effect, because atom is same here in A, B, and C. Now move to resonance. So resonance in B as well as in C. You can see this negative is in alternate with the double bond, and here negative is in alternate with the double bond. So both B and C are in resonance but not A, so A is again wrong. So now we have to compare between B and C. So look at here the important information. I am going to discuss this one in this way. Look at here. Suppose we have a species like this, clear, and we have a species in this way. Clear? Or suppose like this. If you are going to draw its resonance structure, it will donate and it will break like this. In this way. So this 1 and 2 are identical resonance structures. Why identical? Because oxygen is negative, oxygen is negative. C double bond O, C double bond O. Everything is same. So once you have these kind of things, so this is called identical RS, and in identical RS 1 and 2 have equal stability. So if you look at the stability, 1 and 2 are equally stabilized, clear? But if you look at this one, it donates and it breaks like this. Makes sense? So this is non-identical resonance structure. Why? Because here oxygen negative, here carbon negative. Here C double bond C and here we have C double bond O. So you have to compare the stability, and I discussed resonance structures stability. Negative or more electronegative element is more stable. So, and I think the first one is more stable, as well as you can apply the very first rule of stability. More the double bond, more will be stability. So this one is having a benzene ring which has more double bond than the second one. So first one is more stable. So basically what is here the key point? Whenever you have a compound, if it is going to form an identical resonance structure, then that is more stable form, because it will contribute equally to the resonance hybrid. But once you have a non-identical resonance structure, that is not going to contribute equally. One is going to contribute more in hybrid and one is less in hybrid. Clear? So identical resonance structure are more stable than non-identical. Suppose we are going to compare the first and second stability. Most of them is saying like this will form more resonance structure, so more stability. No. If you have the same type of compound, then you can compare like that, like this. Suppose this one I am talking about. In this case, you can say yes, more resonance structure, more stability. But once you are going to compare two different compounds like this one and this, then you have to think about identical and non-identical. Identical is always more stable than non-identical. So in that case, this one will form identical resonance structure, but phenoxide is not going to form identical. So we can say C is more stable conjugate base. That's why more acidic. Clear? Now next is find out the strong base. We all knew basicity is directly proportional to electron donating group. So more the donor group, more will be the basic strength. And yes, we have methyl group here as well as CH2 group. It will donate more. Makes sense? Chlorine is electronegative, fluorine is electronegative, and ammonia is a very short one. There is no donor, no withdrawing. But we have a donor in compound in option B, so we can say this is the strong base. Okay, now next C6, question number 6. Acid having highest value of K. Highest K means more acidic, means acidic strength should be high. And we know that, look at here, we have done this already. Oxygen of carboxylic and oxygen of this benzene one. This one is more stable conjugate base. Okay, let's remove the hydrogen, negative, and here negative. So if you applied here cardio, C for charge is here not the deciding factor. A for atom is also not deciding factor because every atom is here oxygen. Next, resonance. So resonance is only in A, B and C. So resonance, but if you look at the resonance, it will form identical and it will form identical, but not the C one. So the race is between A and B here. Clear? Because both will form identical. But one thing you must have to remember, if you are going to move the next effect in cardio after R, that is dipole induction. So conjugate base is stabilized by the withdrawing group, not the donating one. Here methyl is a donor one. So this is unstable. So stable one is my A. So A is more acidic. Which of the following has the lowest value of dissociation constant? Lowest means low Ka. So Ka low. That means you can, here by fluorine we have fluorine, here bromine and bromine. So we know that fluorine is a strong withdrawing group, but bromine is less withdrawing. So of course C and D can be right choice between A and B. But if you look at the distance, this is the dipole induction is also depend on the distance. So if it is close, that has maximum impact. If it is very far from the carboxylic group or any other group, that has the least one. So bromine is quite far in option C than D. So I think C can be the right choice because that has the lowest Ka value. Clear? Now question number 8. Bronsted-Lowry base. So what is Bronsted-Lowry base? Bronsted base. Bronsted base are proton acceptor. Proton acceptor. Okay. So if you look at this one, COH to CO minus, there is a loss of hydrogen in the right hand side. So this is a proton donor. So this is Bronsted acid. And if you look at NaOH to H2O, this NaOH and this H2O, there is an extra proton here in the right hand side. So this is a proton acceptor, so Bronsted base. And we all knew conjugate base is formed by the removal of proton. So this is my conjugate base and this is conjugate acid, and it is talking about base. So base is my what? NaOH and this one. So which option? CH3CO minus Na plus and NaOH. Option C. Now move to the next. 1 molar solution of each of the following acid was prepared, which would give the lowest pH. So that is a good question. Lowest pH it is talking about. Lowest pH. pH low means acidic strength should be high, and acidic strength is directly proportional to Ka and inversely proportional to pK. Okay, so here we have pK. So strong acid means pK must be low. Okay, so which one has the lowest pK? The very first one. So A is the right choice. So always correlate in this way. Clear? Low pH, strong acid. Strong acid, high Ka. High Ka, low pK, and low pK is only in option A. Now move to question 10. Which of the following molecule would be the strong acid? So again remove the hydrogen. Okay, so whenever you are going to apply the cardio, always form your conjugate base. So conjugate base means here this hydrogen leaves, so O minus, here this hydrogen O minus, here and hydrogen, then this one, and this hydrogen leaves, so there is a negative here. Clear? Now apply charge effect. Charge, everyone is in the charge position, so this is going to be failed. A is called atom. Atom is here what? Oxygen, oxygen, nitrogen and carbon. I can write here. Here my atom is oxygen O minus, here oxygen O minus, here carbon negative and here nitrogen negative. And if you look at the positioning of element in the periodic table, it is like this: B, C, N, O, F. So left to right it increases. So oxygen is more acidic than nitrogen and carbon. So D and C is wrong. Now here we both have oxygen. Now the next deciding factor is my resonance, and you can see option B is in resonance. So B is the most stable conjugate base in the given option. So B is a strong acid. Clear? So you can apply cardio in this way. Now move to next. This one. Which of the following molecule below is the most acidic? Again, we are going to generate its conjugate base by removal of a hydrogen. So this hydrogen O negative, this hydrogen, listen, this is already positive. So once you remove the hydrogen, it will be neutral, no charge. Cancel out this, just lone pair. This H plus O negative, this H plus O negative. So what is cardio? Charge. Charge is what? If you look at the charge, we can say positive charge is more acidic than neutral and then negative. So in this case, we have the neutral one is option B. So B is more acidic. Clear? Now the next one, which of the following is strong acid? Question number 12. Remove the hydrogen. So it will become SeH negative. It will become GeH negative. It will become Br negative and it will become AsH2 negative. Now we have to look at the periodic table and just compare the positioning here. I can remove this. Okay, look at here the periodic table. BCNOF, chlorine, bromine, iodine, oxygen, sulfur, selenium, tellurium, nanoparticles. Okay, so now we can compare the elements. Selenium we have here Se, Ge, Br and As. Now look at here, very easy. If you are going to apply cardio, the very first one is charge one, everyone is here charge. Next one is atom. Atom means if you are moving left to right in a periodic table, electronegativity increases and acidic strength also increases. So Br is more right extreme, so Br is more acidic. So the answer will be C. Now next 13. Which of the following labeled hydrogen atom in the following structure is the most acidic? So remove the hydrogen one and generate its conjugate base. So look at here. Here negative, here negative, and here negative, here negative, H plus goes, this is negative. So here in this case, one negative on oxygen and one negative on the carbon. So negative on all the carbon position is not be the deciding factor here. Makes sense, because once you apply the cardio, C for charge, everyone is here charged, everyone. Next atom, I told you that if you have a carbon, nitrogen and oxygen, oxygen is more acidic because it is more right extreme and that is more electronegative. So compound, number 5 is bonded to the oxygen and oxygen has a negative here after deprotonation. So oxygen is more acidic. So answer will be 5, E. Next is 14th. Okay, which of the following is the best describe why acetone is more acidic than propane? So again we are going to remove the hydrogen. So acetone is like this. If you remove this proton, it will become CH2 negative, C double bond O and CH3. And if you look at the propane, it is CH3, CH2, CH3. So if you are going to eliminate the proton from here, it will become CH3, CH2, CH2 negative. Clear? So this negative is in resonance with the carbonyl because it is in alternate with the double bond. Can you see? Negative is in alternate with the double bond. While here negative is not in that condition. So here resonance is the deciding factor. Okay. So you can confuse in conjugation and resonance. What is conjugation? Conjugation is basically, suppose this is not conjugated system, the given compound right now. Once you deprotonate, then there is a resonance or conjugation. So simply you can understand here, if suppose we have this one and this. So now this is conjugation, and if you look at this one, there is no conjugation. Makes sense? So once you have the alternate in the original compound, these species, I discussed a lot with the resonance and conjugation. You can watch my videos, and I have discussed everything about the resonance. Okay. So this is my conjugation, and this is not the conjugated system here and here. But once you deprotonate, there is a conjugation or resonance. Clear? So answer should be C. Conjugation gives you resonance. Makes sense? What is conjugation? Alternate position of conjugate species. What is conjugate species? These are positive, negative, lone pair, radical, double bond and vacant orbital. When these species are in alternate, then you can say this is conjugation. Like here, my double bond and negative charge is in alternate. You can see just one single bond between them. Okay, now the next question, 15th. The molecule below is unusually acidic due to stabilized conjugate base. What is the greatest cause of this stabilization? So once you remove this H plus, there is a negative. But you can see this negative is not in resonance with the double bond. You can see this because between negative and double bond more than one single bond. So when conjugate species is separated by just one single bond, then we can say resonance. But when more than one double bond, that is not conjugation or resonance. So this negative is not in resonance. So C and D is wrong. And also this is not aromatic, because for aromaticity it should be cyclic conjugated, entire ring. So now here you have inductive. Listen, do not think about hyperconjugation. I don't know why this is given to the option. Hyperconjugation only be valid once you have a carbocation radical, clear, and carbon double bond carbon. But you have to check the stability of these things, not negative charge. We are going to compare here negatives charge stability, not double bond. So do not consider hyperconjugation. Clear? Inductive is only the factor here, because in cardio this factor is called dipole induction, and dipole induction is, it means acidic strength is influenced by withdrawing group, and NO2 is a strong withdrawing group. Clear? So inductive will be the right choice. Now move to the next. Which of the following is the most acidic? So I think there is some misprinting here. CH2 double bond, CH2, CH3, CH2. Leave the question number 16. There is some misprinting. Okay. Now move to the question number 17. What are the product of the following reaction? So we know that NaOH break down into Na plus OH minus, NHNO3 break down into H plus NO3 minus. So opposite charges attracts each other. So Na is plus, NO3 is minus. So NaNO3 and OH minus and H plus. So it will be H2O. So which option? NaNO3 and H2O is only option B. Which of the following is the strongest acid? The strongest acid. Okay, so remove the acidic hydrogen, this hydrogen. So there is a negative hydrogen, negative hydrogen, negative, negative and negative. We all knew that electron withdrawing gives stability to conjugate base, and here we have strong withdrawing, which is my fluorine. Clear? And rest is chlorine, iodine and bromine. So fluorine is more electron withdrawing, that's why this is more acidic. Now the next is question number 19. In the following reaction, CH3COCl act as, look at here, lone pair, or even you can say electron pair. Donors are Lewis base, and electron pair acceptor are Lewis acid. So aluminium is an electron pair acceptor and chlorine is a donor, its lone pair is donating. Arrow is very important. Head means towards acceptor and tail means towards from donor side. So chlorine is an electron pair donor. So this CH3COCl act as a here Lewis base. Okay. If my question is talking about which one is a Lewis acid, so we will say AlCl3 because it is an electron pair acceptor. Now the next is molecule that has a conjugate base with the lowest pKb. So look at the wording here, low pKb. Low pKb. It means high Kb. High Kb. High Kb means strong base. High Kb means strong base. Strong base. And we all knew strong base means weak acid, because weak acid forms a strong conjugate base. So weak acid. So weak acid is what? Remove this all the hydrogen. I told you that apply this cardio, the atom one, carbon negative is unstable one, while if you have oxygen, nitrogen and sulfur. So carbon negative, that is my least acidic, that is the weak acid, and weak acid have the strong base character and that has the lowest pKb. Clear? So answer will be here D. Now the next is, which species are Bronsted-Lowry acid? Bronsted-Lowry acid. What is Bronsted acid? What is Bronsted acid? Proton donor. Bronsted acid is a proton donor. So C2H5Li, Li is a plus, so this is minus. H plus, so this is minus. Okay, or even you can say here C2H5OH to C2H5OLi. So there is a loss of proton here. Loss of proton forms conjugate base. And this is a proton donor. You can see C2H5OH. So this side we have hydrogen, but there is no hydrogen. So this is my proton donor. So proton donor is our Bronsted acid. Look at this one. There is a less hydrogen here, means C2H5. There is a C2H5 and this is C2H6. One extra hydrogen this side. So this is conjugate acid and this is my Bronsted base. So it is talking about acid. So acid is my what? C2H5OH and C2H6. Clear? Option number A. Makes sense? This is Bronsted acid, proton donor, and this is a conjugate acid. So it is talking about acids only. Which of the following is the strongest acid? Strong acid means Ka should be highest. Ka highest means pKa should be lowest. And on the given option, the lowest pK is 0.77. So answer will be C. Make sense? Okay, next is 23. Choose the most acidic compound. Remove the hydrogens, generate a conjugate base, O minus, O minus, O minus, O minus. Clear? And apply the cardio. Cardio means charge. Charge means everyone is negatively charged. A means atom. So here we have oxygen and sulfur, two different kind of atom, and if you look at the positioning and periodic table, it is in the same column. So top to bottom size increases. Size increases means acidic strength also increases. So sulfur is more acidic. So answer should be here D. Makes sense? Which of the following is strongest acid? So remove this negative, remove this negative, and here carbon's hydrogen, so you can remove one hydrogen, so it will become CH2 negative, and here this is also CH2 negative, and this is O negative. So here carbon, oxygen, nitrogen and nitrogen. Again look at here, nitrogen, nitrogen, carbon, carbon, oxygen. So oxygen is more electronegative and negative, or oxygen is more acidic. So E is the right choice according to the cardio. Now move to the next. The strongest acid, most acidic. So remove this H, so there is a negative. Remove this H, there is a negative. Remove this H, here we have negative. Remove this H, we have a negative. In this case, if you applied the cardio effect, C for charge, everyone is negatively charged. Next is atom. Atom is here carbon, everyone is in carbon. Next is resonance, nothing is in the resonance, you can see, clear. And the next one is dipole induction. So dipole induction, there is no withdrawing or donating, it is quite same hydrocarbon just. And last one is orbital hybridization. We all knew sp hybridized is more electronegative than sp2 and then sp3. And sp hybridized is a triple bonded one, sp2 is a double bond and single bond is sp3. So this is my triple bond one, sp1, so answer will be D. Clear? Now the next is identify the not a conjugate acid base pair. We have to identify which is not a conjugate acid base pair. Not. This is important line, not. So H2O, there is an extra proton in the right hand side. So H3O plus, that is conjugate acid, so it should be conjugate base. HSO4 negative, again there is an extra hydrogen here. So again this right side is my conjugate acid, this is conjugate base. I minus and HI, once you add a proton, this is HI, so also conjugate acid and conjugate base. NO3 minus, yes, again conjugate acid. Yes, this is not. Why? This is O negative. Once you add a proton here, so it will form CH3OH. That is a conjugate acid. But this is what? CH3OH2 plus. So this is not. Makes sense? So answer should be E. Now the next is 27, which is the most acidic one. Again we have to eliminate the hydrogens of bonded atom. So O negative, S negative, H negative, and here you can use any hydrogen like this, suppose carbon negative. So we have oxygen, sulfur and carbon. Look at the positioning in the periodic table. B, C, N, O, F, chlorine, bromine, iodine. Here sulfur, here phosphorus, here silicon, here aluminium. So my atoms are oxygen. I am going to use a different color. Okay, we can use the red one. Oxygen and sulfur and carbon. Clear? So whenever you have to compare between size and electronegativity, always priority is given to the size factor. You can see oxygen and sulfur. Definitely oxygen has more electronegativity than sulfur. So I said that you have to give priority to the size one. So size of sulfur is greater than oxygen. So sulfur is more acidic. So the race will be between D and C if you applied cardio. C for charge fails, A for atom. So in atom condition, only C and D are left. Clear? A, B and E is wrong. Next is resonance. So which is in resonance? Option number C. This sulfur's negative is in resonance with the double bond but not D. So answer will be C. Now the next 28. Which of the following compound is most acidic? Which of the following compound is most acidic? Again eliminate the hydrogens. Negative, 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 and here this carbon, so carbon is here negative. So one thing is very clear here. Charge, everyone is here charged. A is atom. So carbon and oxygen, these two kind of atoms. So carbon is not possible. Only oxygen is left. And you can see everyone is by carboxylate. Carboxylase is what? This is carboxylic acid. So once you remove a hydrogen from carboxylic, it forms carboxylate. So this is common in the rest of the options. Clear? So here we have a resonance. So resonance is also common in A, B and C and D. So resonance is not the deciding factor. After that, dipole induction. Dipole induction is what? Electron withdrawing. We all knew fluorine is a strong electron withdrawing. So this is the very first carbon bonded with the carboxylic, and we have 3 fluorine. This is also a carbon with the 3 fluorine, but there is a distance. This is a far, this is a carbon, and then you have CF3 group. But this is just in neighboring conditions. So A has maximum impact of electron withdrawing character, and that is the most acidic. Which of the following compound is most acidic? Again, we will eliminate that. Here any hydrogen, so both are symmetrical. D, every carbon atom is same. So again there is no resonance, everyone is here charged, everyone is carbon atom. So dipole induction is not deciding factor. Orbital hybridization you can apply here. sp hybridized, sp2 and sp3, and this is also sp3 single bonded. So sp is most acidic because that has the most electronegative character due to percent S. sp has highest percent S character, which is by 50%. So more the percent S character, more will be the electronegativity. And the last question is, which of the following is not a Lewis base? Not Lewis base. It is talking about not. What is Lewis base? Electron pair donor. Now, if you are going to see electron pair donor, what does it mean? Take your time. Electron pair donor. Electron pair donor means I can donate my electron pairs if I am electron rich. If I will be deficient, then how can I donate my electrons? So electron pair donor means electron rich. And what is electron rich? Electron rich are generally negative charge and lone pair. So this is negative, so this is Lewis base. This is lone pair, and H3 has a lone pair nitrogen. So this is Lewis base. Oxygen has a lone pair, Lewis base. This carbon has negative, so Lewis base. Now boron. If you look at the boron, it has 3 hydrogen. If you have a bit idea about the octet as well as vacant orbital, boron has a vacant orbital as well, and there is a 6 electron around boron, which means less than 8. Less than 8 means incomplete octet. So this is a deficient species, not electron rich, because this is less than 8, incomplete octet as well as vacant orbital. So this is acting as a Lewis acid as well as electrophile. So this is my Lewis acid, rest options are Lewis base. So this is all about the acid and base. I think this is good enough. Okay, we have done all the topics in this problem sheet. Acid and base theory like Bronsted, Lewis, and conjugate acid base. And then I discussed the cardio based questions. So please try these questions, okay? And this is from my side. So thank you so much for watching this, and please subscribe this channel. I will help you a lot. I can promise you. Thank you so much.